Good afternoon, students. In the previous session, we have already discussed about the concept of NumPy array, the anatomy of NumPy array, and also different parameters used in NumPy array. In this session, we will learn to create one-dimensional array. Students, as you know, any arrays can be single or multi-dimensional, and the number of subscript or index determines dimension of the array. The NumPy library offers many functions for creating NumPy arrays or ND arrays of any rank or dimension. NumPy provides about more than 40 functions to create NumPy arrays. So today, first of all, we want to know how to create one-dimensional array. As you are aware that an array of one dimension is known as a one-dimensional array or 1D array. That means one-dimensional array contains elements only in one dimension. So, when we think about the one-dimensional array, basically we can say the shape of the NumPy array should contain only one value in the tuple. Now consider the given diagram. In this diagram, num is an array consisting of 5 elements. Its first element is at 0 index position. Next element is at 1 index position, and so on till the last element at n-1 index position. So at 0 index position, value 2 is stored, and at 1 index position, value 5 is stored in the memory. The index position always started with 0. So the first element of the num array is num of 0. The second element is num of 1. And the next one is num of 2, and so on. The total elements is 5, and so the index position is 5 minus 1, that is 4, started from 0 to 4. Now creating NumPy one-dimensional arrays. As you know, NumPy arrays can be created through several ways. Creating ND arrays using array function, creating ND arrays using arrange function, creating ND arrays using linspace function, and creating ND arrays using formeter function. To create one-dimensional array in NumPy, we can use any one of the given functions, that is array functions, arrange function, linspace functions, etc. First of all, now we will learn how to create array using array function. Now creating ND arrays using array function. The array function creates each individual elements from the pass list as one element of ND array. That means this function takes a list of elements as argument and returns a one-dimensional array. The syntax is array name equals to numpy.array, that is the function, and the parameters is list of values and optionally D type. D type is the data type, where array name is the name of the array, that is just like an identifier. NumPy and array is the functions. List of values includes any list, or you can enter the value directly. And D type specifies the types of values to be stored in the array, and we will discuss about the data type later. First of all, we just learn the simple array creating. Now, for example, the first line is import NumPy as NP. Here, assuming NumPy has been imported as NP. Now in the first example, A equals to np.array. If NumPy is imported as NP, then we use NP. Otherwise, you can also use numpy.array. So here A equals to np.array, and the list is 5, 8, 12 and bracket close. And as you know, array can be displayed by using the print function. So when we supply the function print A, then what's the output? The output will be 5, 8 and 12. It means A is an array containing 3 elements, 5, 8 and 12 respectively. So here the value 5 is stored at 0 index, 8 is stored as 1 index, and 12 is stored as 2 index. That means when we assess the value of an array, then the first value is A of 0, the second one is A of 1, and so on. In the next example, that is example 2, first of all, we create the list, that is the variable lst equals to 1, 2, 3, 4, 5. That means the lst list is created having 5 elements from 1 to 5. Now, when we supply AR is the array name, equals to np.array and lst. That means this array is created by using the list. And when we print the array, then result will be 1, 2, 3, 4, 5. That means the AR array consisting of 5 elements from 1 to 5. Example, we will import NumPy library and we use array function to create a one-dimensional array. I think you have learned how to create ND array using array functions. Now move to the next. Now creating ND arrays using arrange function. The arrange function creates a ND array with evenly spaced values within a specified numerical range. That means these functions takes a start, a stop of a range and the step of interval as arguments and returns a one-dimensional array. The syntax is array name equals to numpy.arrange, then start, comma stop, comma step, and data type. Here start and step values are optional, and when only a stop value is given, the numerical range is generated from 0 to a stop value with step 1. Although the D type is optional and it specifies the data type for the ND array. Now, for example, here the first line, import numpy as np, and the command is a equals to np.arrange 5, 14, 2. Here 5 is the start value, 14 is the stop value, and 2 is the step value. And whenever you apply the command print a, then result will be 5, 7, 9, 11 and 13 is stored into the array A. Here 5 is the start value and a step is given as 2. So the value is increased by 2. So the next value is 5 plus 2, that is 7, 7 plus 2, that is 9, 9 plus 2, that is 11, and so on. So basically, by using arrange functions, array starts with the start values and continues till the stop values by specifying the step values. In fact, the arrange function is similar to Python's range functions, but it returns an ND array in place of list returned by range function. So students, hope you have learned the creating of ND arrays using array functions as well as arrange functions. So in the next session we will discuss about the creating of array by utilizing lim space function and formatted functions. Thank you and have a nice day.